Yo guys, so yeah, welcome back man. Welcome back. So we have this yeah, man. Let me just say this for a while, bro. Like, like with YouTube videos, sometimes I wonder like, will I say welcome back on this video? Am I gonna say like, yo, what's up? Yo boy here doing the math? Yeah, no, but okay, cool. Let's focus on the math. We have a parabola, so now under functions, we're going to do solve problems. Yeah, so we have a parabola here, as we can see. We have a straight line as well. It looks like we have two straight lines, but like, yeah, let's say we have straight lines. So in terms of defining them, I have f of x, I have g of x, right? I'm gonna use the black color. um yeah, I have f of x, I have g of x, and point D, which is an intersection between g of x and f of x. Point D is noted here. It's I need the arrow. Point D is -1 and 4. I also have f, point F. Where is point F? Let me see it. Looking for F. Oh yeah, point F is another intersection. It's another intersection for g of x and f of x. Yeah, and then T and U, they are x-intercepts. Okay, cool. So we have T and U right here. We also have E of x, which is the y-intercept of f, and we have S, which is the x-intercept of G. Yeah, and we have like VW. Oh my god, did they say VW? Okay, we have VW, which is a straight line drawn parallel to the y-axis, and yeah, that's just it. So this is just what we have. Let's see what the questions are going to ask us to do. Write down the equation of the axis of symmetry of f. Ne? Okay, now we like, let's think about it. What is axis of symmetry? Axis of a symmetry is a line that divides a function into two symmetrical parts, two symmetrical sides, right? So the axis of symmetry is that line. So they say this is a 1 mark question, right? So that means you kind of don't have to think about it, right? Yeah, low key, high key, you don't have to think about it. But yeah, so let's think about it. How do you think, or what value do you think, or what equation do you think is gonna be your, what value do you think is gonna be your axis of symmetry for f? Yeah, it's a little bit the interesting thing about this question is that you don't have the turning point. Yeah, but if you had a turning point, it was gonna even be worth more that 1 mark. So think about it. I will also pause, I'll also pause and keep talking. All right, cool. Let's do it. You look at your graph. I'll request the straight lines, and you see that we have the same y value right here. Oh my god. So you realize on this line we have the same y value, right? And the y value is what? The y value is, oh my god. The y value is y equals to 6, right? You have 6 and 0, 0 and 6. You also have 1 and 6, right? These are the y values we have, right? So now we know, like, since we have 0 and 0, no, we have 6 and 6, that's the same y value. If we divide the x values, we add the x values, which is 0 plus 1 divided by 2, we're gonna get half. That half, x is equals to half, it has to be your axis of symmetry, because it's the middle point, it's the middle line, or it's the line that cuts this parabola into two equal sides. And by it cutting it into two equal sides, it means this side will have to be equal to this side, right? So that's where the logic comes from, right? So I mean, you could do it like that, just like how I did it, and say 0 plus 6 0 plus 1, 0 plus 1 divided by 2, which is half, and then you say therefore x is equals to 1 over 2 is the axis of symmetry. Right, a bit tricky, but yeah, we're getting it. Let's go number 2, 7.2. For okay, yeah, for which values of x is f of x decreasing, right? This is also another interesting thing, eh? And remember, with these things of increasing functions, decreasing functions, you know, the simplest way I would say think about it, just go back to the basics. Now this straight line, is it an increasing or decreasing straight line? This is a decreasing straight line, it, nah? And this one is a decreasing straight line, so it. So if we take what we know about the straight lines and we take it to our graphs, you're going to see that on the side, let me use a bigger font, on the side of the parabola looks something like this, né? So on that side, what do you have? You have an increasing parabola, right? But as soon as we go this side, it's giving the decreasing, so that means that side of the parabola is decreasing, and on the left hand side it's increasing. That means if we answer the question of for which values of x is f of x decreasing, I realize I'm gonna run out of space, so let me just write the answer here. So those values of x is gonna be values of x where x is greater than 1 over 2, right? And then you are done. Remember that x is equals to 1 over 2 is the axis of symmetry. From it we get the turning point, the value of x for the turning point, right? We get the value of x for the turning point. So yeah, and from what I've just illustrated with the red lines is on the left hand side you see we have an increasing function, the right hand side we have a decreasing function. So the values of x for which half of x is decreasing is going to be on the right hand side of half. That's what I'm saying, the value is then the next question says calculate the average gradient between of f, average gradient of f between D and E. So now I'll say 7.3. This is just the same as us calculating gradient m of DE, right? And what's the formula? The formula, remember, is a change in x over change in y, or change in x over change in y. Think about it. So the formula is what? It's change in y all over change in x. And remember, by change in y over change in x, I said that this can be y1 minus y2, but remember the denominator will be x1 minus x2, or it will be y2 minus y1, denominator therefore x2 minus x1. You could use any of those formulas, you're gonna get the right answer, right? So yeah, so point is DE, that's okay. So I will say then mine it's gonna be 4 minus 6. Actually, let me just make 6 minus 4. Yeah, so I'm gonna say 6 minus 4. That means if I said 6 minus 4, I'm gonna say 0 all over 0 minus 1. 6 minus 4 and 0 minus 1, right? So that gives me 2 all over 1, which is 2. So the answer here, I mean, these are the calculations, of course. Then the answer here will be MDE is equals to 2. Looking at DE, I'm thinking differential equations. Yeah, that's it. And of course, we can see that on the left hand side, we said that that side is positive. So the values of x, the f of x is increasing that side. Right, so it makes sense that we're going to have a positive gradient. And then they say determine the equations of G. Let's look what we have about G. We have we have 2 points. Nah, let me erase all this that we have. Yeah, we have 2 points. We have this point and we have this point. Nah, we have this 2 points. And guys, I'm gonna say there's an equation. Remember, there's an equation that you can use. That equation, all you do is you use the right equation, you substitute, and it's gonna lead you straight to the answer. So we're gonna use that equation. Now I'm gonna have to erase all these parts. You need them. Just go back to just go back. I think they say rewind. Yeah, there is a formula that we use. You know, there is a formula that we use to sort of get those. What is the formula? That is the question. Ne? What is the formula? So we have y minus y1 is equals to what? Is equals to y2 minus y1 all over all over x2 minus x1 into x minus x over 1 x1. Yeah, so now I'm just questioning myself. I'm like, bro, is this really the question? No, is this really the formula? So yeah, let me check with my sources. That has to be the formula. Yeah, right. We're cool. So if you're thinking, where did we do this formula? We did it in under analytical geometry. So go under analytical geometry grade 11, and that is the formula. So, and of course, as you can see, right, this thing that you have right here is your gradient. Now, so let's go. Ah, damn, what's oh damn. Alright, so let's do the thing. I wanted to do my points, so I have D. I'm gonna write them down here. Okay, cool. Yeah, so we have D and F. So I'll say this is point 1, this is point 2. Right, so that means here I'm gonna have y minus 6. I'm gonna have 6 minus 4, 1 minus 1. Yeah, 6 minus 4, 1 minus 1. I'm gonna have x minus wait, what the, this is y1, so this will have to be minus 4, and then y2 minus y1, y2 minus y1, and that means this is y1, so this right here is gonna be plus 1. I can just say y and transpose already. I can say plus 4. Then here I have 6. I'm gonna have 2 all over 2. And therefore I'm gonna have x plus 1 plus 5 plus 4, man, and then it's gonna be x plus 5. So yeah, maybe here I can say g of x is equals to x plus 5, and we did. So that means the value here is the value that we have here. It's gonna be what? It's gonna be 0 and 5. Yep. Let's move on to the next questions. What's going on? The next question, it says shows that g of x is this, ne? So you have to low-key, like when they say show that this is this, we have to calculate the what is this? We have to calculate the equations of that parabola. Yeah, we have to find the equation of that parabola. Let's go and look back and see what we can do. So looking at this parabola, ne? Let's see what we can. Cool. So here's what I'm thinking, ne? Because The thing is, I'm like, if we have a parabola, I have to check, do I have my turning point and an extra point? So we have the turning point, but we have only the x value of the turning point. We do not know what the y value of the turning point is, right? And unfortunately, we can't just estimate, right? We must have like a valid reason why we say the y value of the turning point is this value. We have extra points, we have d, we have e, we have f on the parabola. Another way is like, if you have two asymptotes, two x-axis and an extra point, then it's easy to get the equations of the parabola. Yeah, so you could think I have t and I have u, but the thing is, we do not know the value of those parabolas. Like, we do not know the value. Like, what we can do is, let me just do this. I would say I have a straight line here. This straight line is defined by x is equals to half, right? So I know whatever distance this is the same distance this side. So if I can get 1 point, which is u, then I can get t. But that is not the case here. It's not the case here, right? So it seems like or at least let me just speak for myself, I'm having a hard time getting the value of my intercepts, x-intercepts. What I can rather do is, I know there is this thing, so you see f and g are intercepting. Yeah, f and g are intercepting. 7.5. So f and g are intercepting. So if we were to be asked to say, look for the values of d and f, which is the points where f and g are intercepting, I would say f of x is equals to g of x, right? And I would start substituting and so forth and so forth. So let's try to do that and see where we're gonna end. G of x, we did find it was x plus 5, and f of x, I mean, we don't have much, so we can just say it's gonna be ax squared plus b x plus c. Right, we really don't have much, right? So let's just do that. And it looks like we're gonna have a lot of let me see. Okay, cool. So the interesting thing, or the interesting part, is that we don't have to worry about c, because remember, c is going to be a y-intercept where x is equal to 0, so the value is 6, né? So that means here for c, I'm gonna substitute 6, right? You could also do it other ways, but I'm not sure which one's is gonna really be helpful. So from f of x, you could say a into x plus p x squared plus 6 is equals to x plus 5. But yeah, let's go with this way. I mean, it makes more sense for me right now. So we have 2 points, remember. This is gonna work. Oh yes, we're gonna have some like simultaneous equation, and this is our starting point. Name. So cool. So the points of intersections, I think I remember d being -1 and 4. I remember f being 1 and 6. Let me go and verify. F 1 and 6, d minus, yes. So I'm gonna use d first, So if I use d for x values, I have what? I have -1. So I would say a into -1 squared plus, maybe skip a line. A into -1 squared plus b into -1 plus 6 is equals to -1 plus 5. That's the first thing, which is just a minus b plus 6 is equals to 4, right? Which is, I will say a equals to b plus 4 minus 6, which is b minus 2, right? Let me erase this part. That's us substituting d. So if we substitute f, then we have, remember, it's just substituting the x values. So we're gonna have a into 1 squared plus b into 1 plus 6 plus 1 plus is equals to 1 plus 5. So I have 6 right here. I have a plus b plus 6. Nah. And what seems to be the case, it seems here we're gonna have something like this. We're gonna have a is equals to, because the 6 are gonna just cancel out each other, so we're gonna have minus b, right? So this is, I would say this is equation 2, this is equation 1. So then I'm gonna substitute equation 2 into equation 1. This is like simultaneous equation chapter 2. And then so I have a equals to b, right? So where I see a, I can just put minus b and say minus b equals to b minus 2. So I transpose the b, or maybe let me transpose the 2 this side and bring the b this side. So I have what? I have b plus b, b plus b, so 2 is equals to 2b, therefore 1 is equals to b, right? So if then 1 is equals to b, that means a is equals to minus b, and therefore a is equals to minus 1, and therefore in this function of f of x is equals to ax squared plus bx plus c, I'm gonna have a is negative, so minus x squared, b is positive, so plus x, then plus 6, now which is exactly what they asked us to do here. I hope it made sense. It was such a beautiful thing to do, man. Yeah, it's such a beautiful thing to do. Yeah, so these guys, they were breaking our minds, man. Like, hey, yeah, so that was quite nice to do, man. Let's see. Calculate the length of SU. So SU. So they say calculate the length of SU, ne? And first and first, I can get point S. It very simple, very easy. It's easy to get point S. They gave it 5 marks, and I'm gonna tell you why they gave it 5 marks. Because U is the x-intercept of the f function, and for us to get the U, we're gonna have to calculate the x-intercept of the f function, which is a lot of work. Oh, it could be a lot of work. So let's do that. Let's do that. This was 7 point, so I'm doing 7.6. 7.6. So x-intercept y equals to 0, so I could say x-intercept y equals to 0, so I have 0 minus x squared plus plus x plus 6. I divide by negative all sides, then I have x squared minus x minus 6, and you just open 2 brackets. This is factorization, right? So you're gonna have x here, 2 values, you multiply, they give you 6, you add or subtract, they give you minus 1, that's minus 3, and positive 2. So remember 0 0, that means therefore x is equals to 3 or x is equals to minus 2. So we have one positive x, one negative x, so that means that u is gonna be the positive x value. So this is what? This is 3 and 0, right? We have that coordinate. That's the coordinate we need. I mean, we can also say here t is minus 2 and 0, né? But we don't need it for now. I don't know if we're gonna need it later, but we don't need it now. So we go on, we move on, and us moving on is us saying let's find s, né? Let's find s. The equation for s, né? It's a straight line. G of x is equals to x plus 5. So x-intercept y is equals to 0, so y is equals to 0, x plus 5. So that means x then is equals to minus 5, right? So that means that you're gonna calculate the distance from where? The distance from minus 5 and 0 to what? To 3 and 0, which is gonna be 8 units, né? It's gonna be 8 units. You can see 5 plus 3, but let's do calculate it step by step using the distance formula. Delete. Delete. So 7.6 distance formula, distance of SU, that's gonna be square root of y1 minus y2 squared plus x2 minus x1 minus x2 squared. So here I'm gonna have what? I'm gonna have 0 minus 0 because both y values are 0, and I'm gonna have minus 5 minus 3 squared, right? So that's gonna be square root of minus 8 squared, which is square root of 16. This is 16, which is then 8. So yeah, we're done. Distance is 8. We move on. 7.7 seems to not gonna be much of a challenge. 7.7, determine the values of x for which, man, love it. Wait, damn it. So they say determine the values of x for which f of x is f of x minus g of x is smaller than or equals to 0. So technically they're just saying find the values of x where f of x is smaller than or equals to g of x. Now, so in this case, the points that they want us to find, g of x has the greatest y value, right? Because f of x has the smallest y value. So we're looking for points on the graph where g of x, I'm gonna say this, you can find the solution to this by first using it mathematically, or like using the formulas. Now you can just substitute the formulas and try to find those values, or you could go back to your function which they drew for you. You can go back to your functions and find those values. Now since it's 2 points, I'm just gonna go to my function. So remember, g of x has the highest y values. Now cool. If I look at this graph, let me erase everything I see here. If I look at this graph, now this parabola of mine, and I'm trying to find the x values, the x values where the g function is greater than the f function. What I can realize is that if you look at any value between x equals to -1 to x equals to 1, you look at any values there, for any x values in that interval, there's a car passing. For any x value between -1 and 1, you see that the x values of f are greater. The y values of f are greater, right? Yeah, the f values are greater, man. The y values of f are greater than the y values of g. Damn. So in this thing, right, I can pick up this x value right here, right? If I pick up this x value right here, this is the y value for g, but this is the y value for f, right? I could pick up here, if I pick up here, this is the y value for g, but this right here is the y value for f. So anything in that interval, we happen to have values. Let's pick up maybe this x value and say we go up. If I go up here, I have this, right? The y value for f, it's this y value, but then for g, it's this y value. You see that? Let me go here. I have a y value here. Let me use a different color. I have a y value here, but then for g, my y value is right here. So you see that any value from x greater than 1, my y values are greater for g of x, and the same is true for below -1. Let's test it out. So I can go up here and say this is my y value, right? This is my y value for f, and then for g, this will be my y value. You see, so I'm having higher y values. So just like I said, this is 2 marks. You don't have to think much here, man. So to answer 7.7, you're gonna say it's a union between minus infinity to -1 union from 1 to positive infinity, right? That will be your answer, and then you're done. And then they say calculate the minimum or the maximum length of VW, right? Yeah, the maximum length of VW. I will delete. I believe that's 7.8. Erase. So this is VW name. That is VW, and I am asked to calculate the maximum length for VW. Okay, let's pause and think about it. It seems a bit tricky. Let's pause and see where the tricky part is. Right. So this is very tricky, né? It's very tricky because you do not know what V is, you do not know what W is, right? And the thing is, this is one of those questions that can humble you. So I'm gonna take it slow. So when you look at it now, I kind of like, we could draw a straight line here. Sort of, we could extend VW and say V have the same value of X. So Vx is the same as V Wvx is equals to Wx. They have the same X value name, but what is not the same is what is the Y values. And actually, for us to calculate the distance, you're gonna say Vy minus Vwy, right? It's gonna be the distance, because I mean, if you do the distance formula, the same X values are gonna cancel out each other, and yeah, what's left will be the Y values, and they will give us the number we want. So what gives us the distance here? It's the Y value of V minus the Y value of W. That's gonna give us the right. So, and the thing here is that V it's on F. V is on F, so we could say F. No. We could say F V at X. Yeah. Technically, I'm just saying the Y value of V. Yeah, the Y value of V of X. Then minus G, which is W there, right? Then I would say W, right, of X. That is going to give you your what? It's going to give you the distance between those two, mathematically speaking, right? And the more you think about this, you realize, look, I can't, like, it's very difficult. I don't know, because we are working with nothing here. We are working with nothing. So I'm gonna copy this, paste it to the next page, and we're gonna keep working from there. Paste. So let's work. Right, let's work. What is V? What is f of x, ne? So f of x, it's given by minus x squared plus x plus 6. Then minus, we're going to have minus x minus 5, which will be our distance. Alright, so we have minus x squared. The x's are going to cancel out each other, right? And we're going to have a plus 1. Plus 1 is equals to d. Right, so here what matters is it depends what the x value is gonna be, right? It depends what the x value is gonna be for whatever value of x that's whatever value x is gonna take on. You're gonna add 1 to that value, and you're gonna have what? No, you're gonna add 1 to the square of that value, and then you're gonna have your distance for VW, right? But since the question is like, what is the maximum distance, then what is the maximum distance, I'll pause and say, what do you think you're gonna do here? Yeah, think about it. So I'll ask you a question. Let me just write it this way and say D. I'll ask you a question, eh? What if D is equals to 0? Ish, sorry man, before that question you realize that for whatever value that, for whatever value that D is gonna take, ne, that X is gonna take, it's going to be smaller than 1. Do you see that? The value, the distance, so we can be just the distance here, it's gonna be below 1, because there's no way it's gonna be above 1 when we have this minus x squared. There's no way, ne? Because soon as the squared number here, the negative squared number is greater than 1, we're going to have a negative distance, which does not happen. So for us to have a positive distance, the distance is going to be smaller than 1, right? And yeah, and the thing is, the question that I asked, which I shouldn't have asked earlier. Now I'm asking it now. What if x is equals to 0? So you see, if x is equals to 0, you're gonna have a distance of what? You're gonna have a distance of 1. Distance is gonna be 1. Right? If x is equals to 0, yeah. And then can x? Okay, so it doesn't really matter here. Né? X, the values of x, possible values of x, it's gonna be like maybe values between I would say maybe -1, not including, to what? To +1, not including, right? And you realize that any value here that's not 0 is gonna result with the distance being smaller than 1. Yeah, any value in this interval that is not 0 is gonna result in the distance being smaller than 1. So it means that the maximum value that D is going to take is what? Is 1 if x is equals to 0. So, and then D, remember, then that will be the maximum distance for VW, right? So these were tricky questions, but I won't lie. I hope that my explanation was quite good, and it improved your understanding on parabolas and straight lines, and yeah. So good luck, guys. Good luck. I think on the next video it will be hyperbolas and probably exponentials as well. So yeah, good luck, guys, and enjoy.